So how do you graph a quadratic function? Here's how you do it. The first step is to find the x-intercepts. To do that, we're going to use the zero product property. So we're going to set this equal to 0 because the x-intercept is when y is 0. And we have to factor this as a product of two binomials so we can utilize the zero product property to figure out what makes it 0. So let's go ahead and factor this. To factor this, we're going to draw a generic rectangle on the side. We see that x squared is over here, and then we have 6 x tiles, and then we have 8 ones that must go over there. So now we're going to use the diamond problem to factor and figure out what the 2 x tiles must be. So that we know that the product of diagonals have to be equivalent. So x squared times 8 must give us 8x squared, and the sum of these 2 x tiles must be 6. So what two numbers multiply to be x squared, 8x squared, but combine to be 6x? Well, we know it must be 4x and 2x, because 4 times 2 gives us 8 and 4 plus 2 gives us 6. So we know that 4x and 2x goes over there. And then we're just going to go ahead and figure out the sides. And there you go. So we have x plus 4 times another x plus 2. So x plus 4 times x plus 2. And there you go. Now that we have this factored, we can utilize the zero product property to find our two zeros, or two roots, or two x-intercepts. We know immediately this one has to be -4 because -4 plus 4 makes it 0, and 0 times whatever still gives us 0, so -4 is our solution. The other one is x equals -2 because -2 plus 2 has to be 0, and 0 times anything is still 0. So our two x-intercepts must be -4 and -2. Okay, so now that we have both of these x-intercepts, let's go ahead and graph them on our coordinate plane. Okay, so we know that a parabola in this case has two x-intercepts. Now, we also have to find the vertex. The vertex is exactly in the middle or in between the two x-intercepts. So if we have the x-intercept of -2 and -4, what is right in between -2 and -4? What's halfway? Well, we know that the middle, the vertex, must lie at x equals -3. -3 is right in the middle between those two x-intercepts. Okay, so now we know that x is -3. So then how do you find the y coordinate for that vertex if we know that x is -3? Well, since we have an equation or a function that shows the relationship between x's and y's, we can simply just plug it -3 into our equation to find our output, or the y value. To do so, we're going to just plug in -3 using parentheses. So since x is -3, that is being squared, plus 6, and again x is -3 plus 8. Now we can find our solution for y. So y equals -3 squared. -3 times -3 is a double negative positive 9. 6 times -3 is a -18 plus 8. Now to simplify this, we get 9 minus 18, which is -9, and then -9 plus 8 is -1. Therefore, our vertex, or the middle point of a parabola, whether it's the highest or the lowest point, must be -3 for our x, and then -1 for our y. So let's go ahead and plot this point into our coordinate plane. And there you go. So now we have 3 points. We have -2 and -4 as our two x-intercepts, and we also have the middle vertex, -3, -1. Now, it turns out you can also technically graph another point. Now, you can totally plug in other numbers on the number line into x to find the y value. You can plug in -4, -5. You can also plug in 0, 1, 2, any of those points to find more points on this parabola. However, the standard form equation immediately tells us a very special point called the y-intercept. The y-intercept is where the graph crosses the y-axis, which is where x is 0. So if I plug in x is 0, that should tell us the y-intercept. If I plug in 0, that goes away because 0 squared is 0. But what happens if I plug in 0 over here? 6 times 0. Well, 6 times 0 is also 0. So what are we left with? 8. So immediately, the standard form equation already tells us the special point, the y-intercept, 0, 8. So immediately, we can graph the y-intercept of 0, 8. And there you go. So again, we have these 4 points, but since parabolas have a very special symmetrical property, we can already predict where the other point must lie if we know that y-intercept. Since the y-intercept is over here, we can also estimate the other point on the other side of the reflection line. So if the point is over here, then the other point must be over here. And there you go. So now we have 5 points in our parabola, and so we can go ahead and graph the parabola. And there you go. Don't forget to include the 2 arrows on both sides, because the parabola has a domain from -infinity all the way to +infinity, or the domain of all reals. It keeps going left and right forever. And here the range we see, the lowest to the highest point, the lowest point for the y values is -1. But since it continues up forever, the range is -1 all the way to +infinity. And there you go. This is how you graph a parabola, or a quadratic function.